Good Friday morning, everybody, and welcome to our Friday class. What a weird week we had. We didn't have school on Monday. We didn't have school on Tuesday, and we really jammed in a lot of work on Wednesday and Thursday. Um, Thank you for working hard this week. I know getting all that stuff kind of put together and working hard on it is tough. So I appreciate your hard work. Doesn't go unnoticed. So I appreciate you guys really buckling down and getting those assignments done. So you're almost done with the week. These are your last couple assignments for the week. So just like last week, I was able to sort out how to get all this into one video rather than have multiple videos. Also, last night, what a great showing and turnout for the movie Soul last night that we watched on Disney Plus. I'm glad you guys got to come. I know some of you guys couldn't stay the whole time or came a little late and had to leave or whatever. That was awesome that you guys got to show up. So I'm happy that you guys were able to do that. And I think it was quite a success. So maybe we'll have to talk about it on Monday if we want to keep doing some of those evening movie nights. But we do need to focus on today, and today we need to log into Canvas. Before we get too far logging into Canvas, I do want to do our weekly reading. I know that we're obviously not meeting in person, but it's important for us to still do our reading. So I do have a reading ready for you guys and scheduled to get going. I know earlier this week we had a couple readings. Let's continue on with our readings today. We are going to do the lunch to go. Lunch to go, if I remember correctly. Sometimes I forget which ones I assigned with all the moving around of all the assignments this week. So, lunch to go. I see these guys, brown paper bags, obviously, indicating they're going on to lunch or carrying the lunch to school, or maybe they're even going on a field trip. Lunch to go. And here you are. One lunch. Take a peek inside this lunch bag. Oh man, the words are so hard to see. Let's see if I can. Aha! Look at that. Will this let me do this? Nope. Aha, here we go. Maybe this is a little better. Can't see the whole thing now. I don't know if I like that. Let's go like that. Take a peek inside his lunch bag. There is a turkey sandwich with lettuce, tomato, apple, a carton of milk, and a bag of chips. Oh, how did you keep the milk cold all day? Otherwise, that milk's gonna go bad. It's a simple lunch, but at one time, no one on Earth heard of these foods in a lunch bag. The foods only exist on different continents. I need to zoom in. 4 continents to be exact. Over thousands of years, explorers, traders, settlers, soldiers carried food across the land, bringing new foods to people in other places. Foods traveled across deserts, over mountains, along rivers, but foods rarely crossed oceans until 1492, when an explorer named Christopher Columbus sailed to the other side of the world. This bag lunch was brought to you by the explorers, soldiers, settlers, and traders who carried these foods around the world. Yeah, looks like a good sandwich right there. That's a pretty red apple. Wait, they didn't say anything about chips in there, did they? Oh, they did say chips. I was going to say. We're going to have to do a poll question on Monday. What is your favorite chip? If you only had to eat one chip for the rest of your life, what would that chip be? That's your homework for this weekend, is to find out what is that one chip that you would eat for the rest of your life. I think I got a good idea which one mine is. Remember, it's got to be a chip, not a cracker. A chip. Foods across the ocean. Christopher Columbus sailed west from Europe across the Atlantic Ocean looking for the continent of Asia. Instead of landing on the continents of North and South America, called the Americas, people lived in Europe didn't know this land existed. Columbus was looking for spices such as cinnamon and pepper. Cinnamon is good. What he found were foods that he'd never seen before. Corn, beans, chili peppers, and more. He brought some of these foods back to Europe. Other explorers brought other foods home with him. People all over the world began to eat foods from the Americas. I mean, that right there, corn, bean, and chili peppers, that sounds like a pretty good taco to me, and I'm a big taco fan. We had fajitas earlier this week. Yummy. News of Columbus's journey spread. Soon the other explorers and settlers crossed the ocean. They carried new foods to the Americas from Europe, Africa, and Asia. The foods in our brown bag were about to meet each other. Here is a story of their journeys. So you can look over here. What are the Americas? So the Americas are the continents of North and South America. So right here and right here are known as the Americas. So here are some foods that they found in the Americas. Columbus's voyage. These foods traveled across the ocean from the Americas to Europe. Sorry, from the Americas to Europe. That include squash, the tomato. Hello, the tomato didn't exist over here during that time. The avocado. Yummy. Yes, I had avocado earlier this week. I like to have it with my salad and my fajitas and all that. Potato. Yeah, hello. We like potatoes. We like French fries. It could be French fries until someone brought the potato over to France. Peanuts, chiles, and beans. Some foods that, after Columbus's voyage, that traveled from Europe to Asia and Africa. So basically, these foods going to the Americas and going over to Asia. Lettuce, cabbage, an orange, a lemon, a pear, an onion, bananas. I love bananas. Lentils and rice. Good foods all around. Good foods all around. You can make a whole dinner just out of eating these foods. The apple's long journey. Oh yes, the apple has a heck of a journey. We all know the story of Johnny Appleseed, but where did these apples start out at? The apple's long journey happened around 10,000 years ago. So it's a slow movement, but it got around the world. Spot number 1, wild apples grow in Asia. They check in. Number 2, apple trees grow in China. So you can see here, this is China, just pretty close to that. So, and then the apples make a leap through traders and travelers over here to Egypt, and apple trees are planted in Egypt. And then the Romans started to grow the apples in Rome, Italy. And then the Roman armies bring apples to England as they're going around and conquering nations. The Roman armies bring them here. And then last but not least, the apple finally is brought to North America. And definitely apple was a part of the American culture. You always see the phrase, nothing is more American than an apple pie. And look at that. An apple isn't American at all. In fact, it's Asian, which is kind of interesting to see that travel here. But we've kind of adopted it to our culture. The sandwich from 4 continents. It takes food from 4 continents to make a turkey, lettuce, and tomato sandwich. That's kind of cool. Turkey, gobble, gobble, gobble. People in North America were the first ones to raise turkey. They raised them for feathers and food. When the Spanish explorers reached what is now the country of Mexico, they got their first taste of turkey. They must have liked it because they carried turkeys all the way back to Spain. Bread. To make a sandwich, you need bread. Duh. And for most bread, you need wheat. This grain grew first on the continent of Asia. The first people to turn wheat into bread lived in the continent of Africa. So the bread, your sandwich, began its journey in Asia and Africa. Thank you for making bread. It's good. Lettuce. Lettuce is from Asia and Africa too. Because lettuce spoils quickly, explorers did not carry it back up on their journeys. Instead, settlers brought the first lettuce seeds to plant in America. Smart. Tomato comes from the mountains of South America. People in South America planted them everywhere. Spanish explorers ate them for the first time when they arrived in Mexico. When the explorers returned home to Europe, they brought tomatoes with them. Later, people brought tomatoes from Europe to other parts of North America. So you can see this cool little picture here. It shows you where all these foods that we're talking about. You can see lettuce and wheat here in Africa. In parts of Asia. You can see the tomato is right here in South America. The turkey is here in south Mexico. So all right here in Central America. Look at that. Kind of cool. All just to make one sandwich. Milk from a cow. Before the year 1492, no one in the Americas could drink a glass of milk. No one there could eat cheese, butter, yogurt, ice cream. Whoa! No ice cream. That's because there were no cows in the Americas at the time. There were plenty of other mammals, but that produced milk. You know, like goats. You know, I've had goat cheese before, or goat milk. I don't think I've ever had goat milk. I've had goat cheese. Maybe not. I don't think I've had goat milk. But they were wild animals. If it's not like anyone wanted to try to milk a buffalo, a bear, or a moose. Good point. When Columbus landed in America, he must have missed cows and their milk. He brought the first cows across the ocean to America the very next trip. Corn chips and potato chips. Yummy. Now we're talking. Both corn chips and potato chips are from the Americas too. The potato is from the mountains of South America. Corn comes from Mexico. Spanish explorers brought both corn and potatoes to Europe. From there, other explorers and settlers carried them all around the world. The first potato chips were invented in the United States by a cook named George Crumb. Oh, I love this story. The story goes that a cranky customer didn't like George's fried potatoes, and he sent them back. George got mad. He sliced a potato too thin, cooked it too long, and threw on too much salt. Much to George's surprise, the man loved it, and the first potato chip was born. So it was really born out of anger in Saratoga, New York. Sometimes you go to places and you say, I want some Saratoga chips. And this is exactly what they're talking about. Where I grew up in Cincinnati, they have a place called Montgomery Inn. And it's like a barbecue joint or whatever. And they sell really good ribs and chicken and barbecue sauce. It's great stuff. But one of the things they're also kind of famous for is something called Saratoga chips. And these Saratoga chips come from this area. So what they do is obviously when you slice a potato, you take it and you slice it super, super thin. And then you put it in a fryer and you cook it and you throw some salt on it. And you can dip it in barbecue sauce. Chef's kiss. So good. I can think of it right now. My mouth is getting watery. But you can really, in these chips, you can really tell that they are actually potatoes. Like they just sliced potatoes. You know, like some chips can get kind of thin. These ones, they're delicious. Obviously, corn chips, you know, like tortilla chips, Doritos, those are all types of, and Fritos, those are all types of corn chips. The Great Food Exchange. No matter what food you eat, most of the journeys began thousands of years ago. Travelers and explorers carried foods for thousands of miles until the foods reached the ocean shores. Most food journeys stopped there until 1492 when Christopher Columbus arrived in the Americas. Columbus's journey inspired many other explorers. Little by little, foods of the world began to circle the globe. Today, a simple meal may have foods from all over many continents. Can you describe the journey of one of the foods in your lunch bag? So, one of the reasons why I chose this story on Friday, the weekend of the Super Bowl, is, well, typically before COVID, a lot of people get together, whether you like football or not. It was just a reason to get together, to watch the commercials, hang out with friends. Oh, and by the way, there's a football game on. But one of the cool things, one of my favorite things about the Super Bowl weekend is just the amount of food. I love food. I love football game, kind of tailgatey type of food. That stuff is what I really like. So my idea was that if you guys have a party or somebody talks about where this potato came from, started in the Americas, or if someone has some turkey, or somebody has a tomato, or somebody has corn or bean or lettuce or whatever, you think about this, what we talked about today, and say, hey, do you know where that apple came from? They'll say, well, it came from an apple orchard somewhere in Ohio or somewhere in the United States. Well, yeah, maybe that's where it grew from, but originally it came from Asia. Or where that wheat come from if you're making a big meatball sandwich. Well, first off, in America, we didn't have cows there until Christopher Columbus brought them over the second time he came. We didn't have wheat and bread until that was brought over with other explorers, because that started off in Africa. So just think about that. If you're wanting to be a smarty pants, maybe you can try that this weekend. Little mistake, big world. In 1492, most Europeans understood the Earth as a sphere. It made sense to them that a ship could sail west and reach the lands that lay to the east, like Asia. What they did not agree on was Earth's size. One mathematician calculated circumference, the distance around the globe, at 24,854 miles. This distance was close to correct, but the others calculated smaller distances. Christopher Columbus did not want to try sailing west to Asia. Christopher Columbus did not want to try sailing west to Asia if Earth's circumference was really 24,000 miles. The voyage would be too long. But Columbus chose to believe that a calculation made the globe seem smaller, and this smaller distance made the trip possible. What Columbus did not know that the smaller number was in Arabic miles, not Roman miles. Arabic miles were much longer. It was this mistake that led Columbus to sail west, bump into the Americas, and begin an exchange of plants and animals and ideas that would change the world. How about that? Sometimes our greatest triumphs are mistakes. Sometimes our greatest inventions are mistakes. Sometimes our greatest discoveries are mistakes. So when you make a mistake, don't feel down on yourself. Sometimes it leads to a wonderful discovery or invention or a triumph, just like that story here with Christopher Columbus. All right, let's move on and consult our agenda. And here's our agenda. You will see your video here. I'm thinking about making just one part video. Like I said, I think I finally figured that out after half the year. So what we're going to look at is we're going to go to our AL for reading. This is called Writing, Opinions, and Quiz. So let's go ahead and open up our reading. Let's open this one. Let's open it up in this one. Let's go into reading. Yeah, there's your reading. You go to modules. My mustache is starting to or beard's starting to dig into my lips. It's starting to hurt. I'm gonna have to trim it up. I like to grow a mustache in February because it's so cold outside. Keeps my face warm. Alrighty, so just want to make sure I have the right thing on here. Writing, opinions, and quiz. I don't have that on here. Writing, opinions. Oh, it's just an exam. Oh, how about that? I did it. Yeah, this is it. Writing, opinions, exam. That's all it is. Okay, cool. No lesson to go with this. I was expecting a lesson. Again, like I said, this whole week's been a little messed up, so I'm trying to get my head around what did I plan to move around. So this talks about Reader's Theater. Remember, it's what we did on Wednesday. Then we talked about, what's it called when you perform something out loud? Using real people on a stage. How can you make a scene from a book seem real to listeners? Think back to what those kids were doing when they were doing Reader's Theater. Plays tell stories that have conflicts, usually written as what? If they're having a conflict, they're written what? As what? Number 5, novels and short stories are written in paragraph format, while plays are written in what? What do we call that when plays are written in? Okay. Acts and plays are similar to, acts are divided into, one of those. The set of the play gives the audience a picture of the stories, one of those. And a way of speaking that is specific to a certain group or location is called what? So if you ever want to get on TV or anything like that, I have a friend that's a news anchor here in Columbus. I know he talks about this a lot. And number 10, choose the answer that is a best example of dialect. Okay, example of dialect. Are you going to fight him? Don't even think about fighting him. You were aiming to fight him, weren't you? Did you think about fighting him? I mean, come on, guys. Which one really stands out as different? That would be dialect. Kind of give away something there. Oh, well. Alrighty. So, our next assignments will be, I guess my eye, an acceleration quiz. So let's go into science. You know what? I'm just going to have all these tabs opened up so that way at the end, when I wrap up everything, I can just go to these tabs and I can show you exactly what I'm talking about rather than open up a new tab each time. So we're going to go into science. We're going to go to February 5th. February 5th. And there's 4th, there's 5th. There's acceleration. We briefly talked about acceleration on Wednesday. I know that we had Rose's dad gave us also a wonderful explanation of how our plane flies, especially with the fog. But acceleration, you can accelerate by going faster or slower. Pretty straightforward, right? So let's complicate this put some more science terms in this. All right. Acceleration is characterized by a change in the object's velocity. Remember, velocity is a combination of speed and which way? Speed and which way? Which direction? Which direction? Speed and direction. When an object's direction changes, it is accelerating. Similarly, kind of got that. When an object experiences a change in speed, as in slowing down or speeding up, acceleration can be calculated by dividing the change of speed by time it takes to occur. We'll watch the video to find out more about acceleration and velocity. This will clear up a lot of things.
All over the world at any given time, people in cars are accelerating down highways as they live their busy lives. Acceleration is a type of change in motion characterized by a change in speed. It is not limited to speeding up, however. Slowing down or deceleration also applies. This rodeo horse changes his speed and direction many times in order to navigate these barrels. Change in direction is also an example of acceleration. This is because in physics, acceleration is defined as a change in velocity. Remember that velocity is an object's speed and direction. In addition to describing an object as simply speeding up or slowing down, we can calculate its acceleration. Acceleration is equal to the change in speed of an object divided by the time it takes for that change to occur. Let's say that you're riding your bicycle along at a speed of 5 miles per hour, just enjoying your day. Suddenly, a UFO comes out of nowhere and starts to chase you. You pedal faster to get away, increasing your speed to 15 miles per hour over a 5-second time span. Now, the first thing you'll want to know, just after you get away from a UFO that was chasing you down the street is, what was my acceleration? We first need to calculate your change in speed for the numerator. We take your final speed and subtract your initial or starting speed. 15 minus 5 is equal to 10 miles per hour. Now take the change in speed and divide it by the amount of time it took to occur. In this situation, it was 5 seconds. 10 divided by 5 is equal to 2. The unit for your acceleration is miles per hour per second. This means,
because of this unit right here and this unit right here, those units can't go away. When you divide something, they don't go away. So you simply keep the mph over second. It's just they put the little slanted dividing line like this rather than just keeping it straight up and down. But you can do 10 over 5. That number can change, but these things can't. So you got to keep those together.
That every second that passed as you pedaled faster to get away from the UFO, you increased your speed by 2 miles per hour. Good job! You might be thinking, wait a minute, I would like to hang around and see the UFO, not run away. Well, for you curious types, your acceleration would be a little different. Let's say that you're cruising along at a nice 5 miles per hour on your bicycle and a UFO comes down. You are not scared at all, and you hit the brakes on your bike to a full stop in 2 seconds. Since you slowed down, your final speed is 0 miles per hour. When your initial speed of 5 miles per hour is subtracted from that, your change in speed is negative 5 miles per hour. A negative change in speed indicates slowing down or deceleration. When the change in speed is divided by the 2 seconds it took to occur, your acceleration is negative 2.5 miles per hour per second. Similar to change in speed, a negative acceleration indicates slowing down. We see examples of acceleration all around us in nature. The planets of our solar system are constantly accelerating around the sun with constant speed, but changing direction in their respective orbits. Water molecules accelerate toward the center of the Earth, drawn downward by our planet's invisible force. And our galaxy, the Milky Way, rotates around the black hole at its center as it accelerates away from all other galaxies into the ever-expanding universe.
Alrighty, so does a skydiver experience acceleration when free falling towards the Earth? Yes, a skydiver's speed will increase every second until the force from the air and friction balances the gravity at about 120 miles per hour. That is falling fast. Newton's second law of motion. Alright, what happens when a force is applied to it? The first law of motion describes inertia. It says that you have to apply an unbalanced force to move an object at rest or change the motion of moving the object. Think about this. I was actually explaining it to Eleanor. about what inertia is, because we were going sled riding. We got in the sled to top the hill, but we weren't moving. I had to get us to move first, apply an unbalanced force when we were resting to change the motion. I pushed us until we went over that hill. That's the first law of motion. Second law of motion, Newton's a guy who understood this and discovered it. What am I saying it right? Discovered it. Who actually understood it, because you can't really discover something. Sorry, I guess you can't discover something. Sorry there. As you begin the second law, you can add a new term: net force. Net force is the sum of all forces acting on an object. For a force is measured in newtons. N. Why not name it after yourself? You invent something, you can name it after yourself. The first law, or discover something. That's right. The first law just says that if the total of the forces, positive and negative, acting on an object is 0 newtons, the object will keep doing what it's been doing, sitting still. If I didn't push on the ground, Eleanor and I would still be sitting still on that sled. That is the law of inertia. Study this illustration to find out what the second law of inertia is. So here's Newton's second law of inertia. The acceleration of objects produced by a net force is produced by the magnitude of a net force in the same direction of the force as before. So small acceleration, large mass, large acceleration, large mass. So how do we find force? You simply take the mass of something and the acceleration of something and you multiply it. F equals ma. Right here, guys, this is physics. So force equals mass times acceleration. What does the second law of motion say that the change of motion of an object depends on? Well, the second law of motion says that the change of motion of an object depends on the size of force and the mass of an object. So remember, force equals mass times acceleration. Acceleration, self-check. What have you learned so far about acceleration? Well done. You have finished the last section of this lesson. Take this quick quiz, practice quiz about acceleration. If any questions, you can always go back and rewatch this. So what does speed measure? Speed measure how fast an object is moving. Remember, velocity measures speed and direction. What does acceleration measure? The rate at which speed changes direction. Whether it goes left or right, slows down or speeds up. That's what acceleration is. What variables do you use when you calculate acceleration? So basically, what is the formula? What do you need to get that formula? You need to find the change of speed, whether it's sped up or slowed down, and how long did it take to speed up or slow down. That's what time is. Alrighty. So that does take you guys to your quiz. It's a 2-question acceleration quiz. So you have so far your writing opinions exam and your acceleration quiz. Let's go ahead and move forward, and I'm going to open up another Canvas page because I like to have a lot of Canvas pages. I'm going to move myself around a little bit there, and now we'll go into math. Our math assignments, if we go to page 2, our math assignments listed right here, is the adding and subtracting of unlike denominators. Adding and subtracting of unlike denominators. So we've been doing this for a little while. Now we're being more intentional about it. I've kind of alluded to it. I've kind of done a few practice problems, but now we're going to be really intentional about it. So adding and subtracting unlike denominators. The name of the quiz I have to shorten up because it doesn't fit all into PowerSchool. How to get this out of the way. So finding the least common denominator. You have learned about finding the least common denominator, but let's review this concept before we move on. We're going to watch this video to help review the concept of common denominators. In this video, number lines are used to help see common denominators. Notice the numbers on this number lines are multiples of numbers you're working with. You may remember that the LCD, the least common denominator, is the least common multiple of the two numbers.
We're going to find common numbers on different number lines. Here's a number line for 3s. 3, 6, 9, and so on. Here's a number line for 5s. 5, 10, 15, and so on. What's the first number that's common to both number lines? Yes, 15. Here it is for 3s, and here it is for 5s. Here's a new pair of number lines. The first is 2s. The second is 8s. You're going to find the first number that is common to both number lines. What's the first common number? Yes, 8. Here it is for 2s, and here it is for 8s. Let's do one without using the number lines. Here's 2, and here's 5. The fastest way to find the first common number for 2 and 5 is start counting by the largest number. Start counting by 5 and find the first number that you'd reach counting by 2. Do it silently. Here's another pair of numbers, 6 and 4. Start with the larger number 6 and count by 6. Find the first number you'd reach counting by 4s. Here's another pair of numbers. Which number are you going to start counting by? Yes, 8, the larger number. Write the first number that you'd reach counting by 8 and counting by 6. Here are 3 numbers. You're going to find the first number that would be common to all 3 number lines. Which number do you start counting by? Yes, 5. You start counting by 5 and find the first common number you reach counting by 4s and counting by 2s. What is the first common number? Yes, 20. Here's the number line for 5s. Here it is for 4s. Here it is for 2s.
Alrighty, so we're going to find the LCD for these fractions, and we'll click on the problem to find these. So the first common number that 5 and 10 go to, well, 5 times 5 times 5, and then 10 times 2, so we get to end up being 10, right? Because 5 times 2 is 10, so you're already there. 5 over 6 and 3 over 4, our common number is going to be 12. 6 and 9, a little bit tougher, but the common number is going to be 18. 5 and 20, common number 20 because 5 can go into 20. And 3 and 8, this is actually, I feel like the hardest one, and that one's going to be 24. You end up actually just multiplying 3 times 8 to get there. And you can always do that. You can always just multiply the denominators. Just when you do that, you have to reduce the number. Still get the same example though, or same answer though, I should say.
You're ready to add and subtract fractions with denominators that are not the same. Now first we find the lowest common denominator. Here's how we do that. We look at the denominators of the fractions. We ask, what's the first common number for the denominators? What is the first common number for 6 and 4? It's 12. It's the first common number, so it's the lowest common denominator. We write the lowest common denominator for both fractions. Now we find the equivalent fractions for 1/4 and 4/6. First, we figure out the fractions of 1 in both equations. Here, we multiply 4 by 3 to get 12. So the fraction of 1 is 3/3. We multiply 6 by 2 to get 12. So the fraction of 1 is 2/2. Now we complete the two equations. First, the top equation, Then the bottom equation, now we add the fractions.
Here's 4 minus 2/5. You know how to work problems with a whole number and a fraction. You can work the problem the same way when it's written like this. First, we write 4 as a simple fraction. What fraction? Yes, 4 over 1. Can we subtract the way the fractions are written? Right, we can't. So we find the lowest common denominator. We just change 4 into a fraction that has the same denominator as the other fraction. What denominator is that? Yes, 5. We write the fraction 2/5 here. Then we change 4 into a fraction that has a denominator of 5. What fraction is that? Yes, 20/5. Now we copy the sign and subtract. Remember, we're doing the same thing we've always done with a fraction and a whole number. We're making the denominators the same. Let's work this problem. First, we write 8 as a fraction. Both fractions must have the same denominator. What denominator? Yes, 4. We copy the fraction 3/4 here. Now we write the whole number as a fraction that equals 8 and has a denominator of 4. What's the fraction? Yes, 32/4. We copy the sign and add. Remember, when you add or subtract a whole number and a fraction, you can work the problem this way or this way. You make the denominators the same and then work the problem. And you get the same answer if you write the fraction of 1 for the whole number. The fraction of 1 just shows what you multiply 4 by to get 20/5.
Here are some common denominator problems. They are easier to work when they are written like this. So when you're given a problem like this, check the sign to make sure it's a common denominator problem. Then rewrite it like this. If it's a multiplication problem, work it the way it is written.
So let's go over the examples that are given here. So 7/8 minus 4/5. Obviously, the denominators don't match up. So we got to find a common denominator. So the least common denominator here is 40. So the least common denominator is 40. So you got to do the same thing you do to the top as you do to the bottom. And the LCD of 5 and 8 is 40. So you do 4 times 8. You got to multiply both the top and the bottom by 8. And so you get 32, and then you do this top and bottom by 5. Then you kind of have that switch, that flop. So basically just multiply the bottoms and you flip them like 5 times 8 and 5 times 7, then 8 times 4 and 8 times 5. That's your LCD. And now you just simply do the math. 40 minus 35 is 3 over 40. And it's already in its lowest terms. Some more examples. Let me double check. Yeah, so here's another, making sure I had more examples. Again, you just simply take 3 times 5 and 5 times 3. So 5 times 2, 5 times 3, then 3 times 5 and 3 times 4. And that gives you 12 over 15 plus 10 over 15 is 22 over 15. You can, for me, you can leave it at 22 over 15. But for this exercise, I do want you to reduce it down to 1 and 7 over 15. Another example, 4 over 9 is 2 over 6. You can simply just do, again, what we've always done, 9 times 2, 9 times 6, and then 6 times 9, 6 times 4. It gets you 18, or 8 over 18 and 6 over 18. So your answer will be 14 over 18, reduced down to 7 over 9. I will do some of these with you guys. And there's the ones I was going to do with you guys, but I'm going to do it at the end. So adding whole numbers and fractions. So this is a little bit more tricky, okay? So in this case, 7 plus 3 over 40, that one's pretty straightforward. All you simply do is 7 plus 3 over 40 is 7 and 3/40. So that one is pretty easy. But then what makes it harder is when you start adding another number. So, for example, let's try this out. 6 plus 3 over 10. Well, that's simply 6 and 3/10. 1 and 3/4. Well, that's 1. That's 1 and 3/4. You see what we're doing here? We're just adding the 7 and 4 over 9. So 7 and 4 over 9. 3 and 4 over 5, right? Just adding those together. And 5 and the 2/3. That's pretty straightforward. I don't want to spend too much time on that. Alrighty, now, if you can add, you can subtract, okay? So, now you can add, you can subtract. So, this is where it becomes really a little bit more heft to it. So, all you really do is you take this number, 6 over, you know what, let's make this our first examples, and that way we can go from there. So, let me turn my camera on, because I have several other examples I want to show you. And some paper, lights, and let's see here. So I'm going to write down the questions first, and then I will let you guys see my screen. So this is 6 minus 3 over 10 minus 3 over 10, and that is 1 minus, I'll do 3 examples, 3 over 4, and 7 minus 4 over 9. Okay, now I will point, rotate the camera for you guys. Why's my camera? There we go. Aha, okay, so there we go. Let's start with this one. So what we first don't realize is every whole number is really 6 over. It's over 1. So it's going over 1. So this really can be rewritten. This number right here, or this fraction right here, can be written as 6 over 1 minus 3 over 10. That makes it a lot easier, doesn't it? Now that you understand that. So we simply just find a common denominator. Well, let's just do our skill. We take 10 times that and 1 times that, and we have, see here, 6 times 10, 1 times 10, and 10 times 1, and 3 times 1, and that gets us 60. 60 over 10 minus 3 over 10, and gives us our final answer of 57 over 10. Now, I'm okay with you guys leaving it like that. Now, you can also reduce it down. How many times does 10 go into there? Well, it goes into 5 times, so that's 5, and then 7 over 10. And that, make sure, got it? Yep. So let's go to this one. So again, this can be rewritten as 1 over 1 minus 3 over 4. Remember, you guys can pause, stop, rewind this, and go back if I'm going a little too quick. So what I'll do is take 4 times that, 1 times that. So this is times 4, this is times 4, this is times 1, this is times 1. So I'm taking the 1 from over there. And we get our answer as 4 over 4 minus 3 over 4. And that's simply 4 minus 3 is 1/4. Right? 1/4 would be our final answer there. And let's look at this one. Remember, this is 7 over 1, right? It just simply means over 1. That's all you're doing. Minus 4 over 9. So we take 9 times that side and 1 times this side. So 9 times 1, 7 times 9, that's 9, and 4 times 1, and 4 times 1. So 7 times 9, I think, is 63. I hope it is. And then 4 times 1 is 4, and then over 9. And then we have this final. So 63 minus 4 is 59 over 9. Oh my goodness, now I don't know how many times 9 goes into 59. let's see here. 59 divided by 9, so 6 times. 6 times, so what is 9 times 6? See, I'm doing 9 times 6 is 54, so that would be 5 over 9, because 5 more would be 59, so bingo, 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 bingo. That's kind of how you would do that. So I did say I wanted to give you guys some examples, so I'm going to go back and do a couple more examples. I got to go back again. Come on, all the way back. All the way back. So I know I just did some of those, but I do want to give you a few more examples because the denominators here were real easy. They were ones. Let's give you some examples where they're not ones. So let's do, so that says 4 over 9. Let's go 3 over 10, and let's add it, plus, I don't know, 6 over 19. So big numbers. Wow, those are big numbers. I'm already regretting making them that big, but it's okay. So you see, you add it. Well, you guys can't see that. Now you can see it. Let's do another one. Let's do 6 over 7 minus, I don't know why I'm struggling to come up with numbers, 1 over 3. And let's do another subtraction. Subtractions always seems to be harder. 5 over 9 minus 2 over 3 again. Okay, so first thing we do is we need to take this number, multiply it by that side, and this number, multiply it by that side. So if we do this, 10 times 19, 10 times 19, and then you take this 10 over here, multiply the side by 10, and there we go. Now, obviously, I'm using a calculator for this. Let's see here. Clear it out. 3 times 19 is 57 over 10 times 19 is 190, and this is a plus. So 6 times 10 is 60, and 19 times 10 is 190, not 19, I don't know what I was thinking. So there we go. So 60 plus 57, 60 plus 57 equals 117 over 190. And I don't even worry about breaking it down. I like it. Just leave it as it is. Let's try this next one. Same concept. You're going to take this times that side, this times that side, so 7 times 3, 6 times 3, and then this side is by 7 times 7 times 7, so 6 times 3 is 18, I believe, and then 7 times 3 is 21. It's a negative, so you're subtracting. 1 times 7 is 7, and 7 times 3 is 21, so 18 minus 7 is 11 over 21. Okay. And this guy right here, again, same concept. You take this over here, this over here. So 9 times 3, 5 times 3, and then 9 times 3, or 3 times 9, and 2 times 9. So give us, what, 15? This gives us 27, and then 2 times 9, subtraction, is 18. We're going to have a negative number. And 3 times 7 is 27. So don't worry about this whole negative number thing. I just made up numbers. But really, all this is going to be is negative, right? Because 15 minus 18, negative 3 over 27. And you could break that down if you really wanted to, but we're not going to. We'll just leave it as it is. So there you go. Boom. So, like I said, you can always go back and forth, pause the video and go forward in the video if you got that. So, addition, subtraction with unlike numbers. This is your quiz right here. And it brings us almost to our final thing, and that is the fight for land in social studies. There is no quiz for this one. There is no quiz for this one. Just want to point that out, okay? There is no quiz for this one. I just want to do this for the purposes of education. No quiz necessary, excuse me. So, where'd it go? Where'd it go? Fight for land. There it is. Sorry. It took me forever to find that. It was staring me right in the face. Fight for land. The War of 1812. Governor William Harrison, the American leader of the Indiana Territory, became very worried about the growing powers of the Native Americans. Harrison provoked Tecumseh's brother, who is known as the Prophet, in attacking the American army. Harrison knew that the troops by far outnumbered the native people. Many Shawnee died. Tecumseh was so angry about the needless loss of people that he banished his brother from the tribe. Oh, that's tough. While all this was happening, the tension was mounting between the British and the Americans. Many Americans believed the British were supporting Native Americans' people and actually providing them with weapons and attacking settlers. Remember, we talked about that earlier this week. That's a common practice: is to arm your enemy's enemies, is to give money to your enemy's enemies, to give resources to your enemy's enemies. As a result of this war between France and England, American ships were being captured on the sea, both by England and France. America wanted to trade with both countries and did not want to be involved in a war. They wanted freedom of the seas, and they began to fight for the freedom in the War of 1812. Journal entry. I have a journal entry already from earlier this week, so we won't make you do this journal entry because you guys do my journal entries. Fighting the British. From Tecumseh's point of view, this was a perfect time to pull all the Native American peoples together to fight with the British against the Americans. As a youth, Tecumseh himself had already fought with the British during the American Revolution. It was known by them. In the beginning, he was quite successful, but eventually, after a series of disastrous battles in which he took part, the British surrendered, leaving Tecumseh and his men to fight alone. Tecumseh died bravely, as did the efforts to unite the Native Americans against the settlers. But the war continued. James Madison was the president of the United States during the War of 1812. Americans fought for more than 2 years. In 1814, an army of English soldiers came to Washington, D.C. and burned the Capitol, the White House, and the other government buildings as well. Dolly Madison was the president's wife, and she was at home at the time the White House was burning. She stayed in the White House, although she knew her life was at risk, and packed important government papers in a trunk. She left Washington with a trunk and a painting of George Washington just in time for the White House went up in flames. Talk about a wild story there. The American battle at Britain at battle. The British began firing at the fort. There happened to be an American lawyer on board the British ships who was a part of the group that had come to ask for the release of his American prisoner. His name was Francis Scott Key. Some of you guys may know who this is, and maybe if you watch the Super Bowl, at least the beginning part of it, you will hear Francis Scott Key's song. As he watched the rage battle on, the rockets flying through the air, got a hint yet what it is? Through the air towards the American fort, he was deeply moved to see the American flag on the fort continue waving through the clouds of smoke. Francis Scott wrote a poem about this experience, called this the Defense of Fort McHenry. He gave it to his brother-in-law, who set to a popular British tune that we now know as the Star-Spangled Banner, the national anthem of the United States of America. Interesting story how that came about, huh? Started off originally as a poem. The Battle of the New Orleans was one of the biggest tragedies of 1812. Andrew Jackson was a general in the American Army and took 5,000 American soldiers to New Orleans in January of 1815 to defend the city against the British. He did not know that in December of 1814, the American England had met in Belgium to sign a peace agreement, and the war was already over. General Jackson won the Battle of New Orleans in 1815 after killing over 2,500 British soldiers. Only 21 Americans died in this battle. While Jackson was considered a hero for success, the battle wasn't necessary. You know, it's a thing back then. You couldn't jump on and text somebody, hey, the battle's over. You couldn't go on the internet and find out the war is over. This took place in Belgium. This took place thousands of miles away over an ocean to a different continent to find out that there was already a peace treaty, but it was too late. 2,521 people have already died. for a war that already was signed off as a peace agreement. So the United States flag. You have studied the flag in previous social studies courses. Did you know the following facts as well? In 1777, years after the war, years before the War of 1812, the Second Continental Congress passed a resolution about the United States flag. This resolution said the flag must have 13 alternating red and white stripes and 13 stars against a blue background. It didn't say how big these should be or how they should be arranged. You get it? 13 stripes, 13 original colonies. That's why we have the stripes. Each star represents a state. Obviously, we have 50 stars now. And I'm drawing a blank. The red means something, the white means something, and the blue means something. If you want to make a little homework assignment out of that, tell me what the red, white, and blue means. I forgot at the top of my head. I have to research that again. So we are almost done. Okay, almost done. There's no quiz here, but we are almost done. And actually, we have to go back to page 1 here. And on page 1, I forgot to mention that you guys need to do your mini mystery science number 17. Here, I'll just go in through this. And if you guys go here, go to discussions. It's in discussions. Yes, a discussion post. And if you go into discussion post, and we're doing number 17, this due on Feb 5, if I can find it. There it is. Mini Mystery Science number 17. So this one's kind of cool. I'm asking the questions. What do you think the first computers were like? Ask an adult in your life if they remember the first time on a computer. I remember exactly my first time on a computer. In Mr. Mouch's class, typing on an Apple computer, learning how to do keyboarding skills. And then later went over to Andy Reuter's house, and we learned something called American Online. Ask your mom and dad about if they know that, what American Online is. Ask them. I know they all had one, or at least had to have known someone who had one. Ask them what their AOL name is. You got to say it right. AOL name, American Online name. What their AOL name is, or the AIM name is. American. It's the Messenger. Something cool. I remember my very first one. It was kind of cool. And then what will computers look like in 30 years? So you guys should look into computers now. Hey, think back 30 years ago when computers were invented. You're like, oh, Mom, I can't believe you guys had computers back then. Well, 30 years from now, someone's going to say that to you guys. So think about what that looks like. So here's the link to the video. This is the exact computer that I started off on. It's an old clunky Macintosh computer. This was like high tech back in the day. So it's a really cool mystery here that you guys should watch. Alrighty, so recap everything. Mystery Science, number 17, discussion board post. I'm curious to read those. Next is the writing opinions exam, and then the acceleration quiz. Then the add and subtraction with unlike decimals, or unlike denominators. And then there is no quiz for the last one for social studies. So enjoy your weekend, and I will see you bright and early Monday morning.